Welcome everybody, thank you for attending the very last talk of the day. I realise it's been a bit of a long stretch. Hopefully I will keep you entertained enough to not fall asleep. If you do fall asleep, I would appreciate it if you don't snore. If you do snore, I will pick on you. The talk will be about cognitive services, specifically the Microsoft variant of cognitive services, but I will touch on other things. There's been a bit of a lot of talk actually today around machine learning, and neural networks and that kind of thing. So this ties into that, but kind of tackles it from a different angle. That's me, Paul Glavich, Principal Consultant at Redify, author, former MVP. The industry veteran part is really just a nice way of saying that I'm an old fart, so I have been around for a little while. So again, what I'm talking about today, cognitive services from the Microsoft perspective. How you're going to get it set up. We're going to have a look at the APIs in use, and I know that things like the bot presentation this morning talked about use of cognitive services, so we're going to have a look at the actual API calls involved, what some of the responses are, how ridiculously easy it is to actually use. We're going to have a demo as well. We're going to demo the API calls, but there'll be a bit of an interactive demo later on as well. So if you've got your device with you, I will be asking you to perhaps send emails my way, and we'll do a bit of on-the-fly analysis. Hopefully, we won't be flailing while the demo fails. That would be optimal. And then we'll talk a little bit about where I see the future is going, and then obviously we'll wrap up. So just the AI overview in itself. So I'll be talking about cognitive services, obviously, but that's really for me anyway, that's the pre-built, pre-trained models. It's the really easy stuff to do. It's dev and human friendly. So it's a real easy target to pick. And when adding value to your applications, for example, you can jump into these areas here, but there's a lot more work involved. And so using the cognitive services that Microsoft has provided you, you can add value to your apps really quickly. They are these pre-built, pre-trained models. So for things like text analysis and facial recognition, you don't have to do anything. You just sign up for them and you just start hitting them and away you go. As we move to the right though, machine learning and bots and then eventually the cognitive toolkit, things get a lot more complicated. I think if you were here for Dom's presentation earlier on, you saw some of the Azure ML factory where you could build and train your own models. But there's a lot more work involved to get an output from that. But you can, obviously, there's a lot more customization involved, but it's a bit more time. Going towards the cognitive toolkit, that's kind of another level again, and you're looking at things like TensorFlow, which is kind of the Google equivalent, and it's all just script-driven, coming up with your own neural networks, deep learning, and really getting involved in that kind of stuff. It's pretty heavy, so you really need to know what you're doing. I tried looking at it, and it was pretty much blank stares for about half an hour before I kind of gave up. And I did have a full head of hair before I started doing that, and after that, I was done. But anyway, we're looking at here, as you go across there, there's significantly more time, but more flexibility. But again, this is kind of the high value, I guess, part of the Microsoft landscape in terms of cognitive ability. So, cognitive services, again, they are just all about APIs. APIs. So there's about 30 of them in total, which is quite a lot. About 7 or 8 months ago, there was probably about 24. So in that time period, they've increased by 6, which is significant when you think about some of the things that go behind the scenes to get that to happen. So one of the things for myself, so around cognitive services, it's at the start of every year or so, I like to sort of look at the tech landscape and think, all right, what's a good thing to pick up? What's going to sort of become prevalent really soon, or something that I need to learn about? And for me, cognitive services was it. And again, I'm no data scientist or I'm not very good at machine learning algorithms, but for cognitive services, being just APIs, I know how to do APIs. I'm an app dev, so that stuff's really attractive to me. So there's a current list, and it's done this way on purpose, so you can't really read them all. You really don't want to. But there is a significant amount there. And I mentioned that I kind of, at the start of the year, looked at cognitive services and thought, yeah, that's going to be cool, I'll pick something up. But to target all of those is going to be really hard. So I just sort of decided to target a few, and then once I get my head around it, I'll expand out. And that's kind of where a lot of the emphasis in this, this presentation will go, predominantly around text analytics, emotion, and a little bit of vision. A lot of people have spoken about LUIS, the Language Understanding Intelligence Service. They use it behind bots, and that's pretty popular. And I didn't want to do what everybody else had already done as well. So while LUIS is sort of the favourite child, again, I decided on text analytics and looking at other APIs as well. So we won't be looking at that one. Again, the text analytic API, as well as some emotion and vision, but text analytics detection of sentiment is something good, something bad. What are the key phrases in a block of text? What's the language of that text? And also what kind of topics are identified in that text. With the emotion API, you can detect facial expressions and where the faces are. And again, we'll have a look at, I haven't mentioned it here, but we'll look at the vision API as well in brief. And that one's actually really powerful. It can detect a whole range of categories and items within an image just by pointing it at the image and saying, go for it. Being APIs, and if you're an app dev, you know, you're literally just standing on the shoulders of giants, and that you can use these building blocks to plug into your application. And we'll see how that works a bit later as well. However, it's not just about Microsoft. There are plenty of other players out there. Google being one, AWS, there's even Salesforce there, IBM's another, there's a whole range of players out there. You know, if I was to put my money on another competitor to say Microsoft that I thought would be doing really good and is worth investigating, it'd be Google. It's not to say that the others aren't doing well, but I think Google has a really, is sort of moving really fast in that landscape. They've got some really similar APIs, they have, and they're almost similar name too, like vision and emotion. They're available there, and they actually work in a really similar fashion. They've got websites that you can jump in and have a bit of a play around, and it's pretty easy to get a handle on. They have this TensorFlow, which is their equivalent of the cognitive toolkit in the Microsoft space. TensorFlow is, again, a scripting language. It's pretty much for rocket scientists. Well, not quite that, but they also acquired a company called Kaggle. So they do machine learning competitions. And they've got this thing called DeepMind, which is this company that they've acquired recently. And it's all about AI research and coming up with machine learning solutions to certain problems. And if you go and Google DeepMind, they've got some really cool videos of some of the stuff that they've been doing. And one of them is where you've got a, it's kind of like a 3D person, and using the machine learning that they've developed, they can get them to do parkour against all these virtual objects, the application of which will eventually be physical movement. But it's really cool, some of the stuff that they're doing, and it's worthwhile looking at. Microsoft have recently established their AI research facility in the same vein as DeepMind. It's not as a competitor, but to do the same things. So all this stuff is being taken really, really seriously, and I kind of feel like we're just on the cusp of things. You know, these companies are providing these APIs and all these bits and pieces, but it's really going to ramp up big time. AWS has got their own bits and pieces. Salesforce, as I mentioned, you know, they're doing not exposing consumer services insofar as the way Microsoft and Google perhaps are, but then they're detecting imposters by tracking action patterns against all the massive amounts of data that they have and providing that as sort of value add to their customers as well. So there is quite a few out there. Oh, I forgot to mention API.ai in Google. I've been doing a little bit of work with that as well, and that's a really nice user interface on sort of like the language understanding service. You can type in example phrases and it goes and shoots it off to machine learning and starts to pick up and learn how to understand phrases. And so it's a really nice way of coming up with that kind of conversational bot approach. They call them agents. However, we're here to talk about Microsoft Cognitive Services. So we're just going to go and I'll take you briefly through just how to set them up. You can set them up manually, which I will show you here. But you can do it via ARM templates, which Dan was mentioning in the presentation prior. PowerShell, yeah, there's a whole range of ways to do that. So let's just jump out of here for a sec. And so I'm just going to the Azure portal now. assuming the internet's all good. Excellent. Okay, so I'm just looking at this resource group. I've got some cognitive services resources. Let me just increase some of that. So all I've done to create these guys, I've got emotion, cognitive speech, text analytic, which we'll be using, and vision. It's got all Glab there, just in case you didn't know I was Glab. And they're easy enough to add. You click add and you type in cognitive services. And we should be able to see them. Oh. Cognitive services there, and you can just go and select one and add them in. There's not much to them. If I click on this guy here, the only thing you really need to know from them is 2 bits of information. Most important is the access keys, and yes, you are seeing my access keys here, but after this prozo, the thing's pretty much going to be torn down, so I'm okay with that. So you need an access key, and you also need, if we go back here, the location. And you can see cognitive resources here. I've got in the West US for the most part. They're the 2 key bits because they go towards forming the URL. And all you do is add them in. They're pretty low cost. You can have like hundreds of thousands of requests going to each one of these, and it's pretty cheap. I don't know the exact figures, but I've been running these for some time and I've hardly been charged anything. So we've got the location, we've got the server, or the access key for the service. We're pretty much good to go. With that, we can form this, the REST call. We can determine or work out the URI. You can see we've got a location there, which would be West US in our case. The service might be emotion or vision. We'll get an API version, might be v1.0, v2.0, and the action, that might be sentiment or key phrases or something like that. So it's easy to come up with the URI, it's quite simple. And this is pretty much standard across all of cognitive services. There's only 2 bits of information, well, 3 technically. This content type, which is typically application.json in the header, and that OCP APIM subscription key. That'll be that access key that you found in the portal. So as long as you supply that as the headers, you're good to go. Now obviously there's usually a body that goes with that, and that'll be specific to the call that you're making. In the case of sentiment analysis, again, it's all a simple JSON structure. You can see an example up here where we're describing what language it's in, the ID and the text that we want it to analyse, and we can have multiples of those. That ID is just used to correlate the response. So if you do 100 documents, you go ID 1 to 99 or 100, the response will also have those IDs so you know which response correlates to what. You can see the forming of the URL there. Simple request response, and we've got English, Spanish, French and Portuguese languages supported, with 12 more in preview. It'll be interesting when we have a look at some of the other APIs, just even in text analytic. The language support sort of differs between them all, and I'm not sure why it's a little inconsistent that way. It's a bit odd, but just something to be aware of. Okay, so quickly, let's have a look at the sentiment analysis in action. So I'm going into Postman here. And there's my URL. As we saw before, West US, we've got text analytics, version and sentiment up there. Our body, this is really awesome news, and this is crap news. So I'm going to go over here, hit send, go down here, and we should see some response. There we go. So you can see the response. We've got our IDs to correlate the response. We're getting a score of 0.9. For this is the really good news. So anything close to a 1 is really good. Anything close to a 0 is really bad. So with the really crap news, we've got 0.04. So this is the way you get a lot of the weighted scores, especially for text analytics, but even with some of the other services as well. Everything's between 0 and 1, and you get some sort of floating point number in between. It's up to you to decide what the thresholds are. Obviously 0.5 is kind of neutral. And everything above that is somewhat positive, and anything below is kind of negative, or if it's 0, it's really negative. So it's kind of up to you to come up with those thresholds, but it's easy enough to work out what's good and what's bad. If I change, this is crap news to this is sort of okay news. Let's see what the value. So the previous value, 0.042, hit send, 0.25. So, it's better. So and it couldn't get much easier than that. Okay. So that was sentiment analysis. Again, very, very easy. Behind the scenes, just doing quite a bit of running through pre-trained models for you, but you don't have to worry about it. Send off some goop, come back, all good. Key phrases works in much the same way. We've got the JSON, which is almost identical. A little bit of a different URI, just really key phrases on the end there. Request response. Again, with the I mentioned the languages, it's slightly different. So if I go back, we've got English, German, Spanish, and Japanese. And on this one, we've got English, Spanish, French, and Portuguese. Do I know why? Not really, no. It's just the way it is. I guess, well, I would imagine it's probably easier to pick out doing certain analysis for certain languages, so they're just picking the easy ones first and moving on to the harder ones. That'd be my guess. Okay, so key phrases. It's going to look much the same as the sentiment analysis example. So if I go over here and choose key phrases. Okay, so I've still got the same input. This is really okay news and it's totally crap. We'll go send, go down here, and you can see what we've got here. The key phrase was news. On the other one, key phrases was crap. Fair enough. Again, pretty easy. We've got the IDs back to correlate that. If they found more key phrases in there, you'd see it listed in the key phrases as an array of strings, similarly down here as well. But it's not rocket science. It's quite easy. Finally, language support. Again, nothing new here. It's a little bit different in that you're not supplying the language as part of the input. It does support 120 languages. It's still request synchronous response kind of thing, request response. URI is a little bit different, but nothing major here. So in terms of a demo, it's not going to look too much different. But if I go to language, I'm coding a new JavaScript framework called the Behemoth. And we've got some other stuff down there, which Google Translate kind of gave to me. So let's, actually, what I forgot to mention is in terms of the headers, there are the headers there. I did mention the content type and the APIM subscription key, and again, application JSON and the access key. So I'll just hit send on that, have a look at the response, and the detected language was English, and you got the code there, and Afrikaans for the second one. And the ISO 36391 name as well. And the score, sorry, in this one being 1, so it's supremely confident that it has got the right answer. So if it was unsure, you probably get a score of maybe 0.7, for example. Okay, so the last one in the text analytics suite is topics. This one's a little bit different. The JSON structure is kind of similar, but you do have some other options that you can provide in there. The stop words that are excluded from topic detection, and stop phrases which are excluded from the results. So if you've got common stuff that you really don't care about in terms of topics, you can provide that to try and fine-tune the response. However, this one is not request response. It is one of those ones where you submit a request and you've got to ping to see if it's done. It requires a minimum of 100 documents to be submitted. And when I say documents, that could be a simple sentence or it could be a big chunk of text. Now ideally, with any text analytic analysis, it wants the blobs in as small as possible, because if you've got this big body of text, doing, for example, let's say topic analysis or even sentiment analysis, there could be a number of ranges of sentiments within a large body of text. So if you're shrinking it down, you get more accurate results on those smaller bodies of text. With topics, again, it's something that you'll submit the big blob to, and it's designed that way, and then you've got to ping it waiting for a response. It's not a quick operation in that it can take a few minutes at a minimum. I've got a unit test that I've been using, and it takes like, I don't know, 6 to 8 minutes to actually run through, so it's not exactly an exciting demo as we sit there, refreshing all the time, waiting for it to come back. But there's a bit more complexity to its operation. Not a great deal. We've got the initial URI that we submit to, so it's that languages. As part of the response from that, it'll go, okay, I'll give you a 202 accepted code, and it'll give you this operation location header. And in that is an actual URI that you can go and ping to try and it'll give you an operation status. Let's see if I can zoom in on that bit there. And in here you can see we've got status of succeeded. There are other statuses like running, submitted, failed, not started, that kind of thing. So it is a little bit different. It does take a bit more time to run through, a little bit more code in the back end to try and get that to work. So it's about the only different one in the analytics suite. Okay, on to the next one. So that's the text analytics range of API actions. The emotion, it's another really easy one. It can detect happiness, sadness, surprise, all those interesting emotions. You can supply an image URI, or you can upload an image. Similarly with videos, you can do a video URI, you can upload videos as well. URI follows the same pattern there. So again, very much the same. Now, let's go have a look at that guy in action. And yeah, and emotion. So if I have a look at the body, I'm going to supply that URI. And let's go have a look at what that is first. Some random dude. I actually went to a facial recognition site and they provide all these kind of images that you can use for free. So I thought, yep, I like free. All right, so let's go back to the API call. Hit send on that. Okay, so we've got the face rectangle describing where the face is. And we've got different scores in much the same way that you saw with the text analytic and sentiment analysis and everything. You've got a range of scores in between 1 and 0, indicating whether an emotion is present or not present. So most of them aren't present, except for happiness, which is getting a 0.9. So it reckons that the guy is reasonably happy. And again, it's up to you to come up with the thresholds that what does, a 0.56 in surprise mean? I'm not 100% sure. It's really based on your own specific use case. But, this is not complex stuff. You're utilising a really strong back end, but the results here, really easy to interpret. Vision. Computer vision. This one's actually pretty cool, I think. Some of the stuff that you get returned from this is actually there's more that comes back than, say, simple things like sentiment analysis and emotion. It can actually categorize the contents of an image. It finds faces, much like emotion does. It can determine if it's got mature or adult content. It can determine, you can find celebrities, landscapes, colors, all these kinds of things. So the URI is similar, but we've got these visual features and details. And these visual features, you can supply what categories you want returned. And the details sort of fine-tune it. You can determine whether it's going to be, was it landscapes and celebrities, I think, to some of it. So here's all the list of things here with categories. Categories according to taxonomy defined in documentation. That's really helpful. The results are actually much more helpful than that. Tags, description. This one's really interesting. Describes an image with a complete English sentence. So it actually gives you, tags and words to describe the image, but also gives you a complete English sentence. You don't have to do anything and try and interpret it and make up your own sentence. You can actually provide that, for example, on a website as a description, and it, for the most part, works pretty well. Other stuff like image type, whether it's clip art or line, colour. The adult one is interesting, whether it's adult in nature or whether it's just racy, which is sort of semi-adult, I guess, I don't know. Whatever's definition of racy, which is kind of interesting. Probably the best way to look at it is, let's just see it in action. Postman, here we go. Vision request. So looking at the body, we have got this image, and let's go to that image first so you can see what it is. Okay, so nice enough image. There's lots of detail in there, lots of things for it to report on, so let's see what it does. So you've got that mental image going on there. All right, off to Postman. And you can see here, I've got visual features. I'm asking for categories, tags, description, and adult. If I hit send, all right, so let's get this. So in terms of categories, it's young people, people young. And it's about 76% confident of that. That seems fairly cool. We've got the adult content there. Is it adult or is it racy? Neither of those. And because the adult and racy score that it's giving you there, you can see it's pretty low. So that seems fair. Tags, outdoor, and as you can see it's giving you confidence levels here too. So it's got 99% confident that it's actually outdoor. Now you've got trees, flowers, person, plant, little, yellow. They're all in the image. So that's pretty cool. Description tags. This is where it gets a little bit interesting. I think most of them are correct. You've got outdoor, flower, person, plant, what are we? Holding, small, sitting, young, toy child, wearing, standing. Don't know about that one. Front, bare. Table, there was no table in there. Vase, oh, maybe because there was a flower there. Bench, boy, phone, stuffed. Yeah. I don't know. And I think this is probably the, I was talking before how you can customise, with machine learning, you can customise and train your models suitably. Because we're on the consumer-friendly end of that, and we've got pre-built models, I think there's going to be a degree of variance there where it's not quite going to be 100% exactly what you want. But, this is pretty close. And the captions is really interesting. A little girl wearing a yellow flower. So that's okay. I thought that's actually pretty cool. To discern that from there, yeah, she wasn't quite wearing a little yellow flower, but we'll give it that. And, it's 89% confident that that's the case. So I find that really interesting. That's a pretty powerful API, I think. You could have a website of images, run it through this API, and you'd be getting a lot of information from it, just by doing nothing at all apart from passing it to the API. Now, back to you. Okay, so I talked about at the start that usually at the start of every year I kind of look at some stuff that I think is going to be cool and interesting to learn, which was cognitive services for one part. And the best way to learn is to do, for me anyway. So what I decided to do was come up with a Fluent API around these APIs. So while you can send it off, get a JSON response and pass it yourself, this is all pretty cool. But if we had a Fluent API that did all that parsing for you, and you just sort of throw in a couple of commands in C# code in this particular instance, I thought that'd be a cool way to learn it and get my head around the details. So the stuff that I will show you around this Fluent API, I won't concentrate on it too much. It's just around text analytics and emotion. I mentioned those two, I picked those two initially because they seem fairly simple, but there will be more to come. The API itself does stuff like this. So we can see we've got the text analytic configuration. You give it an API key and a location. So that allows this library to construct up that URI that we saw before. I'm going to set up some diagnostic level at everything. I'm going to add debug diagnostics using HTTP communication with some text analytic actions, add sentiment analysis, key phrase, analyze it all, and you just get back a strongly typed object. So that stuff's actually pretty easy to use, and this library is available on NuGet, and you can see the source code to it and everything like that, and I'll show you that at the end. So we're coming up to the interactive part of the demo. So what I'm going to do is I'll show you a site that's been, that I've developed, that it's actually analysing emails. And in previous dry runs of this presentation, I got people to send me email, and you could see them all coming through. But what was happening was people would send me things like, this demo is cool, this demo sucks. which would be one-liners, which is great. But then the footer would contain a paragraph of email signature that would make it get confused. So in the interactive part of this, if you do send emails, maybe try and scrub the email sig. It'll come through much nicer. So you can actually go to that site, by the way, and you'll see some pre-baked emails I've already sent there. That's actually the email to send to. I'll flip out from that because I will show you that email again. So that, just in short, that's feedbackforglavstalk@gmail.com. So if you've got a device, send some stuff to it, and we should see it come through. Now, if we go over to here. So let's click it on. All right. Oh. So I've got some emails that I sent previous. You can see it's coming from me, the date and time. And we've got some sentiment around it. Some of it's really positive, really negative. There's a neutral one there, somewhat positive, mildly negative, and really negative. If I toggle some of the details, and if you wanted that email address again, it's that guy there. You can see we've got some key phrases here. We've got demonstrations. So in the body, we've got this email is just a demonstration of the sentiment classification engine of cognitive services. Sentiment score of 8.3, and key phrases are demonstration. And we've got in this body, so this weekend is coming to an end. I wish they would simply ban Mondays. Really negative. It's got a score of 2.0 with key phrases of weekend. So, is anybody actually sending emails? Excellent. All right. So while that's happening, because it takes a bit to turn around, I'll just describe how this is happening in the background, because it does take like a minute or so before it all picks up and then analyzes and comes through. So while that's doing that. So what's happening here? Here's my little clicker pen. This is you. You send email. We have a series of web jobs in Azure. We've got one web job which runs every 20 seconds or so, just sends a message to a queue and says it's time to collect email. We've got this guy, another web job that just goes and collects that email when it receives that message on the queue. And then it places it into Cosmos DB. And once it's placed in there, it sends an analyze message on the queue. This web job, when it receives that message, goes and picks up the mail from Cosmos DB, and then it calls out to Azure Sentiment Analysis using that Fluent API that I showed you earlier, and then stores those results back in Cosmos DB. The website there just pings Cosmos DB periodically to try and pick up results, so it's not doing anything spectacular there. Let's just flip back and see if anybody has sent stuff. Oh, we have some stuff there. So we got, well, I won't say the name because I'll probably say it wrong. So we've got two on there. One's neutral, one's really positive. So the first one says, when is beer o'clock? Okay. Sent via Yahoo Mail from home, fair enough. I couldn't pick it up, so it's gone neutral. And we've got a smiley face in there. It says it's really positive, so it's above, it's 79%. In the code, I've said if anything above 75 is going to be, or 75% or 0.75 is going to be really positive. Anything in between 7.5 and 0.5 is actually sort of mild. So if we go back to these examples here, I've got a 0.71, which is somewhat positive, and a 0.29, which is mildly negative. They're purely my arbitrary decisions. It'll be up to you to come up with different versions of your own. Is anybody still sending through emails? I'll leave it up there for a little bit. Just as as an aside, I showed you the architecture previously with the web jobs, the Cosmos DB. The most expensive portion out of all that, oh, there we go, excellent. Oh my God, and oh, food today, interesting, okay. We've got stuff coming through. I'm glad that it's working. So much food today, I'm feeling a bit sleepy as I ate too much. It's interesting that it got a 0.10 on that one, so it's come through as really negative. Interesting test, come through as neutral, seems fair. Oh, worst of times. Oh, okay, interesting. That's actually the best of times and worst of times. It's a really good podcast. Okay, so that's quite interesting how it analyses that. And you can see that it's also including some of the footers in those mails as well, which kind of makes it a little confusing. for sentiment analysis anyway. You know, if you were really smart about it in terms of developers, you might be able to clean all that stuff up prior to giving it to sentiment analysis, which is probably you'd get some better results out of that. But you can see that it's working pretty well. In terms of the code behind the scenes, this is pretty much it. So this is the, if I zoom in here, this is my solution. I've got the email analyzer, which is the web job, and we've got email collector and the scheduler and repository and all that kind of stuff. But essentially, all it's doing is we've got, let's call up this function, which just processes the queue message. It constructs up a repo and sends it off, says, okay, analyze handler, go and do your thing. And if we go to the analyze handler, it goes and gets all the messages from the repo, goes through each message and runs it through the that Fluent API. And that's pretty much about it, and then it just stores it. So you know, we're talking like, well, what do you got? 1, 2, 3, 4, 5, 6, 7. 7 lines, and we can do some sentiment analysis on it. If I wanted to add in extra bits, I could say add topic analysis or language analysis, for example, and also do mail, message, body. No, maybe not body. Or any text in there that I wanted to. And that'd fire off multiple calls and handle calling the API for you as well. So it's just a little bit of a wrapper on top of that. All right. Just to sort of round out the Fluent API part, because I did mention that the topic analysis is one of those different APIs, and that you need to sort of ping, I guess, the operation status all the time to try and get results, which can be a little bit of a painful operation. So I'll just show you a quick example of how that's handled. And if I go into here. So is that text easy enough to read? Yep, good. So we've got some, this is the unit test in the actual project itself that does it. So I'm creating a configuration, setting logging levels, diagnostic, HTTP comms with some text analysis actions. This part here is just going to grab a big blob of text. I won't show you the text, but it's just a large block of, not like Ipsum text, but similar stuff. I'm saying, okay, split it into sentences. So topic analysis is splitting into sentences on that test data. And then do an analyze all. And the assert makes sure that it gets this, it's got an operation location as its result. And then it says, okay, go and check topic analysis status async. So it knows the results it should use to do that. So it gets a result, and it's asserting here in this case that it's not started. So when it's immediately submitted, it hasn't actually started yet. It actually goes back to Azure, goes through some motions before it actually starts to get churning and processing. So that was the first ping on the status URI. And then after that, it just says, okay, let's just wait for the result. Using that result, let's go wait for topic analysis to complete and give it a massive timeout. And then it just sits there and does the pinging for you until the results come back. So the Fluent API makes that process a little bit nicer for you as well. Which is not, again, it's not really that hard to do, but you know, if you don't have to do it, then good. Okay. So we've gone through the text analytic APIs with sentiment analysis and key phrases. We've had a look at some of the emotion API, computer vision API, and then we had a look at that sort of real-time demo. So I've been getting the 10 minutes, but kind of almost there. What do I think the future holds, I guess, in terms of where this kind of stuff is going? And I've only touched on the surface. You saw the 30 APIs, or the 30 groups of APIs previously, so there's a lot more to explore there, and that my intent is to go a bit further into that. But in terms of where is all that kind of stuff going, Microsoft in the cognitive services is providing those Lego blocks or those building blocks for you. And internally, it's making use of a lot of those building blocks. So for me, you know, I think there's going to be a huge amount more consumerization of artificial intelligence. And we kind of see that on sites. Again, I mentioned Google's API.ai. It's actually a good example of that, where it provides a nice user interface to go and interact with machine learning, and I see that getting much, much, much better in the future. So much so that even mums and dads might be able to go and use a site, but not realise that they're doing this fantastic machine learning and huge algorithms in the background. A few more specialised services beyond simple APIs, and I'll jump into that in a second. More compute on the device is where I see a lot of machine learning and AI being sort of spread out to. I think Tatham in the keynote mentioned about Facebook, and that's actually doing some machine learning on an actual device. And where it needs to, it can sort of call out to the cloud to do that kind of stuff. So there's going to be this big split, but it's going to take a little experimentation around how that computational split works the best. And there's going to be, I think, a lot more seamless application integration. The one example here, I don't know if anybody uses Outlook or has seen this little focused tab. That's actually using machine learning in the background to determine what are the most relevant emails for you to look at and present them just in this focused or other view. So on the surface, it doesn't look like machine learning or AI has got any real part to play in it, but in the background, that's exactly what's happening. So it's just servicing this AI in a way that just doesn't look that way. But again, behind the scenes, just taking all those Lego blocks and drawing them all together for you. In terms of specialised offerings, Microsoft offers something like this custom vision AI, which is using the emotion and computer vision in the background, but it allows you to interactively upload images, so you can train it. So you give it some sample images if you want to, if you've got something specific that you want to train it for, and then you can also then provide some other images that it can test it against and evaluate whether it's meeting the criteria that you've set up for it. So again, it's providing almost the best of both worlds, and you've got a nice, instead of using that nice, easy, pre-built, pre-done API, you can actually customise it to suit even more. So let's give you 80% of the way there, you can train it the rest of the 20%. And I see this kind of thing being offered as services a lot more in the future, so you can customise it to your particular business and or use case. So what now? I would encourage everybody to go and have a look at it, even if it's just using Postman and playing around with the APIs. Just pick one of the ones that seems interesting and just have a play around with it. Optionally, you can go into Visual Studio, do a File New, console app, install that package that you see up there, and type in that code, and you will be using things like sentiment analysis in probably under 10 minutes, under the assumption that you've already provisioned something in Azure with an access key at a particular location. And it's that easy. I mean, again, when you think about what's happening in the background, being able to whack out 8 lines of code kind of thing, and it's doing this powerful sentiment analysis or emotional vision or whatever the case is in the background. It's pretty awesome days for innovation and creativity on our part. So that's about it. I hope I've managed to keep you awake the entire time. There's some links to the actual demo source code if you wanted that. The Fluent API is up there as well, and there are NuGet packages to get. Insofar as the demo, I mentioned that the site itself, the most expensive part of it was the Cosmos DB part, and it is chewing through my money at an alarming rate. So pretty much after I leave here, I'm going to tear it down. So the actual site won't work, but the demo code is easily, you can go through it and check it out. Most of it is actually sort of infrastructure and pushing email around rather than the actual sentiment analysis itself. So that's all that I have for you today. Thank you for at least staying awake and laughing occasionally at my crappy jokes. Thank you very much for attending the very last presentation, perhaps on Locknote. Have fun. Thank you.